Alright guys, sorry, I was recording this and somehow I must have turned on and off my camera and somehow I lost the end of it. But I did just want to put it up in case you wanted to check your answers, right? These are the ones we did in class. I already did them. Maybe this is better for you because it'll be shorter. I'm not sure quite where it cut off. I'm pretty sure it did the pounds of flour, right? I needed to figure out he needs 12 pounds of flour. 5 plus 5 plus 2 is 12. The pounds of flour, the bags of flour are sold by 2 pounds or 5-pound bags. So I'm going to buy 2 5-pound bags at $2.89 and 1 2-pound bag at $1.59. Right? This is stuff we might really do. $2.89 times 2, right? When I do times, I can put it in my parentheses. Plus $1.59. I did my math over here. $2.89 times 2. I also just did it the other way. I added $2.89 together 2 times, but I got the same answer, just double checking. Then I'm going to add my $1.59 here. I make sure to line up my decimal places when I do addition, right? When I do multiplication, I count the numbers behind the decimal place in the product, in the factors, and I put that in the product. 1, 2, nothing down here, so in my product I put 1, 2, $7.37. All right, here was my ride at a theme park, like Magic Mountain, right? It's going to take 1.5 minutes for the ride to go, and then 2 minutes for them to get ready for the next people to ride. So how many trips can they ride, or how many rides can they take in 30 minutes? So I'm going to take my 30, and I'm going to divide it up by the number it takes to take one trip, which is 1/2 plus 2. Right, 1/2 plus 2, I'm just going to add my 1 plus my 2 and get 3 plus 1/2. So there it is, 3 plus 1/2. I need to change this into a fraction. So I do 3 times 2 is 6 plus 1 is 7. There's my fraction. And now I'm going to just multiply. I turned my both numbers into fractions. Right, this one, because I'm dividing, I need to change my operation too. I go from division to multiplication, and I find the reciprocal of my fraction. So now I'm going to have 30 times 2 divided by 7. All right, so 60/7 is an improper fraction. I can't leave it like that, right? I'm going to just do my math problem here. Divide 60 by 7. I know 7 times 8 is 56. So I'm going to do 7 times 8, 56, subtract. I have 4 left over. 4 becomes my new numerator, and 7 is now still my denominator, right? I had 7, I keep with 7. So they can ride 8 4/7 of a ride in 30 minutes. But you can't ride 4/7 of a ride in the 30 minutes, right? So I'm just going to round it to 8 on this problem. Normally, if I was doing other kind of rounding, I would round up. I might say they can almost do 9 rides. They're close to 9 rides, but not quite, right? All right, so on Monday, 21 DVDs were checked out at the library. This is 3 less than half the amount of books checked out that day. How many books were checked out, right? The first time I did it, I kind of messed it up. I was going to divide first and then add, but I am going to add my 3 books. 21, it was 3 less, so 21 plus 3, and it was half the amount of DVDs, right? They checked out more books than DVDs. So since they were going to divide by half, I'm going to multiply 2 to find the opposite, the reciprocal, or the, anyway. So 21 plus 3 is 24 times 2. I don't know where I did that problem, somewhere over here. Well, hopefully you could just see, right? 24 times 2. 4 times 2 is 8, and 2 times 2 is 4. I have 48 books. I can write my problem. I don't know why I did that either. Sorry. Anyway, this video will be way shorter. Leo takes 30 minutes to eat dinner, 15 minutes to change his clothes, and 20 minutes to walk to practice. Right, so this is a real thing that you guys have to figure this out. If Leo needs to be at hockey practice at 7:15, what time does he need to begin, right? What time does he need to start eating dinner, changing his clothes, and walking to practice so he's not late? So I'm going to add up my times together. 30 plus 15 plus 20 is going to give me 65 minutes. Remember, there's 60 minutes in 1 hour. So I'm just going to count backwards here. He should have left at, right, he needs to be there at 7:15, so he needs to start getting ready 1 hour before that, which will give me 6 o'clock and plus another 5 minutes, right? I'll take away my 5 minutes here, which he needs to leave by 6:10 to get, or start working. He needs to start eating dinner by 6:10, and so he can be out the door at 7, or so he can be at practice at 7:15 on time. All right, here is Mai Ling. She's going to set up tables for her art class students. Each square table can seat 2 people on each side. How many people can be seated if 8 square tables are pushed together in a row? Right? If I just had a table like this, I could sit 2 people, 2 people, 2 people, 2 people. I could sit 8 people at each table, but we can't here because they're pushed together, right? I'm not going to squish people in the middle. So we can I drew my picture of 8 tables, and then I'm going to just count my sides, right? And when I do that, I kind of cross them out so I don't double count anything. I'll go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. Right, my other way I could do this is just try to figure out, all right, I got 8 tables. Well, 2 of these tables, right, these 2 end tables can fit 2, 4, 6 people. So I'm going to say 2 of the tables can fit 6 people, so that would be 2 times 6. Plus, the tables in the middle can only sit 4 people each, right? 1, 2, 3, 4, and they could sit 6 of those kind of tables, right? 6 times 4. So I would do my math. I'd do 2 times 6 is 12. 6 times 4 is 24. Add those up together. I'm still going to have 36 people sitting at these tables. All right, here was our homework. Here's Nora, but we didn't do it. It's just in case you wanted to practice your homework. Page 781. I know some of you guys are like you want to make sure you're doing this right and doing good. So here's Nora. She earned $50 helping her neighbor. She spent 3/5 of the money on a purse and put 1/5 in the bank. How much money did Nora have left? Right? She still has the money in the bank, but it's away from her hand right now. So how much does she still have? So Nora earned 50. So when I do these problems, right, I want to figure out what I understand. I plan how I'm going to solve it, then I solve it, and then I check my answer. First things I know, Nora earned $50, right? She has $50 and spent 3/5 on a purse and put 1/5 in the bank. What do I need to find out? How much money she has left in her hand, not counting the money she put in the bank. So first I'm going to plan it, and they wanted to draw a diagram, so we'll just use their diagram. They already drew it for us. How nice. So $50 is the total, right? And I know she spent 3/5 on a purse and put 1/5 in the bank, so I'm just going to add those together. 5 on when I add fractions, I'm still splitting up into the same number of pieces, so I keep it a 5. I add my numerators. 3 plus 1 is 4. So I have 4/5. So I'm going to break this up into 5 pieces. Right, I'm breaking up into fifths. I know she spent 4/5 of it, and she's going to have 1/5 left. If I break 50 up into 5 pieces, I get 10, 20, 30, 40, 50. So I know Nora has $10 left. Right, my other way I can do this is with my multiplication. $50, right, I turn that one into a fraction. I'm going to multiply it times the 1/5 she's going to have left. I'm going to say 50 times 1 is 50. 1 times 5 is 5. I divide the top and the bottom by 5. I get 50 divided by 5 is 10. 5 divided by 5 is 1. My $10. I can use multiplication to check my answer. Is 1/5, right? I have 50 over 1 times 1/5 equals 10. So now is 10 times 1/5 going to equal 50? Let's see. So 1/5 times 50. 50 times 1 is 50 over 5, right? I get the same thing, and I get 10 to check my answer. All right, on the back, here's Paul. Paul is decorating cupcakes for a birthday party. He can decorate 3/4 of a cupcake per minute. At this rate, how many cupcakes can he decorate in 12 minutes? Right? If you remember these kind of problems, we would just add 3/4 and 3/4 and 3/4 and figure out when I get to 12 minutes. So I'm going to take my 12 over 1 and I'm going to multiply it times the 3/4, right? Instead of adding 3/4, 3/4 and figuring out when I get to 12 minutes, I'm going to do it this way. I would do 12 times 3 is 36, and 1 times 4 is 4. Sorry, I probably didn't explain that good how it is in my brain, but sorry, I'm going to keep going. So 36 divided by 4, right? 36 divided by 4 is 9. I know 4 times 9 is 36, so I have 9 cupcakes. Sorry, I'm just still trying to remember. How did I say it last time? It sounded better. But, right, I could just add 3/4 together 12 times. Right, because when I add this together, if I had 6/4, I'd have 1 whole plus another half. And this is just 2 cupcakes being or 2 parts of a cupcake being decorated, right? And then I'd have in 2 minutes, this is per minute, 1 minute, another minute, I could decorate 6/4 of cupcakes, right? I already have 1 and another half decorated in 2 minutes, but I needed to figure out how many I could decorate in 12 minutes. Hopefully I didn't make that worse. To make cheesecake, you need 2.5 pounds of cream cheese. How many pounds of cream cheese will you need to make 2 cheesecakes? Right, I can just add 2 1/2 plus 2 1/2. I would add my whole numbers together and I get 2 plus 2. When I add whole numbers, I can do that. When I multiply fractions in mixed numbers, I can't do that. But here I can add my whole numbers together and my fractions together. So I would get 4, 2 plus 2 is 4, and 1/2 plus 1/2, right? When I add fractions, my denominator stays 2, 2, 2. That's why I have to have matching denominators to add them. And I add my numerators, 1 plus 1 is 2, and 2 over 2 is the same as 1, and 4 plus 1 is 5. I have 5 pounds. So what else did I do over here? Oh, I did 2 1/2 times 2 over 1. Right, I could change this. So I'm multiplying 2 1/2 times 2. Right, so I'm changing this into a fraction. I put a 1 over it. Here I need to change this into a fraction. I'm going to change it into an improper fraction. I do 2 times 2 is 4 plus the 1 is 5. I keep my same numerator, halves. 5 halves times 2 over 1. 5 times 2 is 10. 2 times 1 is 2. I can divide the top and the bottom by 2. 10 divided by 2 is 5. 2 divided by 2 is 1. And I have 5 over 1, which is the same as 5. My other way I could do it, sorry, I thought I did it somewhere here. Nope. I could have done 10 over 2 is the same as, right, 10 divided by 2. 10 divided by 2 is 5, because 5 times 2 is 10, and I'd subtract and have 0. All right, here's Scott. He viewed 72 classic cars in a car show. Of the cars he viewed, 3/8 were sports cars. How many sports cars did Scott view? So he saw 72 cars, classic cars. We want to figure 3/8 of them were sports cars, right, instead of trucks or whatever, or big family sedan kind of cars, or I don't know, they're fast, right? Sports cars are faster. So I'm going to multiply it times my 3/8. So 72 times 3 might seem hard. I'm going to just write it out this way. 2 times 3 is 6. 7 times 3 is 21. 216. Right? I could have done it like this too, right? 70 plus 2 and multiplied times 3. I can put a little dot for multiplication. So I would do 70 times 3 plus the 2 times 3. 70 times 3 is 21, because 7 times 3 is 21, and then I put my 0 back. 2 times 3 is 6. If I add 210 plus 6, I get 216. I still have that same number. My denominator is 1 times 8 is 8. Well, I can't leave it like this in an improper fraction. So I'm going to take my 216 and divide it up by 8. So I put can 8 go into 2? No. Can 8 go into 21? Yes. 2 times 8 is 16. I will subtract, right? I'm going to borrow. 11 take away 6 is 5, because 5 plus 6 is 11. Right, my inverse operations. Then I bring down my next number. It's a 6. How many times can 8 go into 56? 7 times. 7 times 8 is 56. 7 times 8, 56. Subtract, I get 0. So I know that 27 of his 72 cars he saw were sports cars. Did you notice that? It's just kind of a little coincidence, but all right. So here is a builder. Sorry, I keep looking. It only has 4 minutes and 44 seconds on my other one. A builder is installing a fence on all 4 sides of a backyard. The yard is 40 feet long and 50 feet wide. How much fencing will the builder need? All right, so I am not measuring the area inside, right? I'm going to put a fence around this. I know this is 50 and this is 40. So if this is 50, this is 50. And if this is 40, this is 40, because it's a nice rectangular with the same nice parallel lines here, parallel lines here. All right, so I can do it a couple ways. I can just add my 50 plus my 50 plus my 40 plus my 40. 50 plus 50 is 100, and 40 plus 40 is 80. So I have 180 feet, not squared, right? I'm just measuring feet, 50 feet plus 40 feet plus 50 feet plus 40 feet. I could also do this, right? 2 times 50 in my parentheses plus 2 times 40 in my parentheses. I could also write it this way, right? This means, when you see this, it means 2 times whatever's in the parentheses. But I could also write it out if you prefer that. 2 times 50, right, the way that you've been doing it and learning it, plus 2 times 40. Either way, we will get 180. All right, and here is Misty. Misty, she purchased a pair of jeans that were originally $24, but were on sale for 1/3 off the total price. How much did she save? How much was it off? How much was her discount? So she spent $24. They cost $24, but she got 1/3 off of that. So I'm going to multiply it times 1/3. So I turn my 24 into a fraction, and I say 24 times 1 is 24, and 1 times 3 is 3. I can divide the top and the bottom by 3. 24 divided by 3 is 8, and 3 divided by 3 is 1, right? I do it this way if I notice that the denominator will turn into a 1, because then I will have a whole number. I could also divide it, right? 24 over 3 is the same as 24 divided by 3. So here I'm going to do it right here. Can 3 go into 2? No. Can 3 go into 24? Yes. Hopefully, right, you're learning your math facts, you know them. 3 times 8 is 24. I got 0. And this took a lot less time than my last video. I hope it helps.